All right, welcome to day 23 of the Leetcode grind. Let's get started. I'm going to try to find myself an easy question to solve here, an algorithm question. If I can't solve within 15 minutes, then I'm going to try to look for the solution. Algorithm. I don't know why, but Leetcode is kind of slow nowadays. God, that's take forever. At some point, I'm going to bump this up to a medium question, just not until January 16, because I still have some more stuff to do this winter and don't have time. Palindrome number. All right, let's see. Okay, this is really easy. You know what? If this is too easy, I'm gonna solve another one. X equal to 121, return true. 121, read it 120 from the left and right. False, because left to right is read. Oh my god. X equal to false. Okay, so return str of x equal to str of x minus 1. Run it. That should be like the solution to it. Okay. I'm gonna solve another one because this one is way too easy. Oh my god. All right, let's see what on earth is go. Yeah, you can do that too. You can do math operation, get it faster, but really, what is the 23rd solution? Y equal to string of x equal to 0, return false, x equal to 0. If x, what on earth is doing? This is exactly what I'm doing right now. If x is less than 0, return false. This is the first condition. If x string and x string at minus 1. Yeah, we can store the result of it in the string, and then we can do x equal to str of x, right? And we can do x at -1 is equal to x at 1 at 0. Ah, it doesn't work. Okay, x at -1 is equal to x. Submit. Okay. How is this lower? I mean, I am storing it inside of a variable, so, but how is this a lot slower than the other one? It shouldn't be any slower than the other one. This is consistently slower. Maybe storing it inside of a variable, slowing it down. I don't understand. I mean, there might be like a page fault whenever you access it, and that might cause it to be much slower, but I don't see how that can be slower. Maybe this is faster. Maybe converting it to string on the fly is faster. I don't know. All right, let's start with another one. This one is too easy. Roman to int. Roman numeral are represented by a 7-digit symbol I, V, X, L, C, D, M. For example, 2 is written as 2 because numerical. Just value. Okay. Oh dear. Roman numeral are usually written in large number to the smallest number to the left. So, however, the numeral is not 4. Instead, the numeral 4 is written as IV because the 1 is before the 5. We subtract it, making 4. The same principle applies to the number 9, which is now instants. So I can be replaced before V, 5 and 10 to make 4 and 9. Okay? X can be replaced before L. So X and C. So to make 40 and 90. X can be replaced with L. L is 50. Replaced before L. What? It makes 40 and 90. Um, C can be replaced with D, making 500 and 1000. C before D. Okay, to make 490. Okay. The number 27 is XX plus V plus II. XX is 20 plus V is 5 plus II is 2 for 27. Okay. Mm-hmm. LVII is 58. L is 50. V is 5. Triple I. Oh. We only grab the first three. If there's a character that is not the same as the previous character, then grab the first three. So V can put in front of X. So if this number is bigger than this number, so L is 50, right? L is 50. Is V less than 50? Is V less than 50? L less than 50. L can be only accompanied by X. So L can only be, if it's an L, then we have to look to see if there's an X in front of it. Because if there's an X, then we minus that number. If there is a V, then we look to see if there's an I in front of it. IV. If there's a smaller number and then bigger number is to the right of it. Okay, so well, first off, we need to keep all of this instead of a hash map for sure. Hash map equal to that. This is when multi-cursor really help. Leetcode multi-cursor. Control Alt. If you're using Mac, Shift Control down, up. Okay. Shift Control down. Okay. Let's just make this sure that we have all of this. Shift Control down. Control down. Shift Command. Okay. We have to do this the old-fashioned way. This is so bloody tedious. X. Control Man. M. All right. So those are the numbers. All right. So we have all this instead of a hash map, right? Shift tab, shift tab, shift tab. And let's go ahead and move this up one here. Boom. Okay. Why don't we just put all of this in line? Okay, hash map. So if there is, we go to the string with a left pointer and a right pointer. If we go to the right pointer, if the right pointer find a bigger number than the left pointer, no. Let's just look at the number in front. Okay. If we find a bigger number, because IV is 4 right here, right? So we have a res. So M is 1000. Is this number bigger than this number? Yes. C and M. Cm, MC. C is what? C is 100. M is M is 1000, right? C and M. M, that number is bigger than this number. We add that to the output, and now we go forward. C, is C bigger than is next letter is C. C and M. Is M bigger than C? Yes. Um, is M bigger than C? No, no, no. We go. Actually, no. We're gonna have a for loop here. We have a while L is less than length of S. So first off, L is gonna be zero. L is gonna be zero initially, right? We have two pointer. All right. Let's just do boom, 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 boom. We have an L here. All right. L is an R, and L is the number next to L bigger than L and R. Okay. Go to R. R is number at C. Is it bigger? Is the number at R bigger than number M? Yes, it is. Okay. Break out of that loop and get that number in there. Oh man, this is hard. Okay, we need to. Okay, if this number is bigger than this number, if that number is bigger than this number, if that number bigger than this number, res plus equal to 1000. Okay, so next up, we're going to put L where R is and increment R. So now R is at M. Is M bigger than C? Yes. Oh wait, we have cur too. Cur is equal to cur right now is equal to cur right now is equal to C. So C, what is C? What is C? C is 100. Right now, cur is 100, right? Cur is 100 because and R is less than M. So we need to find okay. So we need to find a number that is R is less than M. Cur C. Whew, this one is hard. Hmm. If we are at L and L is less than M, can we sort this in some way? If we put all the M in front, if we sort this, nah. Okay, let's just go with the two pointer approach for now. So if we reach L and L is C curves to the only condition that we should get, what is the condition that we should append to this? So right now curve is 1000, right? Curve is 1000 because L plus equal to 1000, and we increment R to C. C is less than M, so we are going to put that to there. So the condition if R less than C, then append, then res plus equal to result occur, right? So if R less than M, but what if we go to the next one? L. L is C less than M? No, C is not less than M. So C is not less than M. C is not less than M. Well, go forward until go forward if C is not less than M, so increment R less than C, then L is equal to R and R, or for loop is gonna be for R in length, in range, length of S. equal to length of S. Okay, so for I in range of for R in range of length of S, res is gonna be equal to 0, and cur is gonna be it's gonna be equal to 0, and then cur equal to 0 again, right? So we have the left pointer here. We don't even need the left pointer. We can just do oh my god, this is hard. So what if we just have the right pointer? We just have one pointer, I here. Is I plus 1 less than I? Is I plus 1 less than I? Yes, that is true. Okay, so initially, cur is equal to be equal to the cur is good to input at I, input at 0, which is going to be 1000, right? So when the for loop start, is cur at I more than cur at I plus 1? That is true. Okay, res plus equal to cur, so that's 1000, and then cur equal to 0 again. Now I is equal to I plus 1, so it's I, no, 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 is I plus 1 less than I? Is I plus 1 less than I? Is I plus 1 less than I? No, it's not. So cur plus equal to cur plus equal to 100. Okay, go forward one more time. Is I plus 1? Is I plus 1 less than I? Yes. M is less than X. M is less than X. So X is 10. M is 1000. Okay, so take M, take index at M, which is 1000. 1000 minus cur, and then add that to the result, which is 900. Okay, and then cur is equal to 0 again. 0 again. All right, go forward one more time. Cur at X. Now X, I is at X. Okay, X is now cur is equal to 10. Cur is now equal to X, which is 10. Is cur at I plus 1 less than X? Less than 10. Cur at I plus 1, which is C. C is 100. No, it's not. So increment. Increment again. Cur at I plus 1. Okay, so C. Is C at I plus 1, which is I. Is 1. Is 1 less than C? Lesser than C? Yes, that is true. So take C, which is 100, minus 10. So add that, which is 90. Add that to here, and keep going forward. If I plus 1, at I plus 1, okay, 1. Is 1 less than, is cur at I plus 1 less than cur at I? No. So we're going to put that in there. If the condition is no, then we're going to add that in there. So that's, now that goes 0. Now cur at I plus 1, which is 5. So the currently is 1, right? So now we just do cur at I plus 1, which is the latest one. And now there's nothing afterwards, so we're just going to do cur at I plus 1, which is V. V, the last one. Now this one, we might get like an index out of Brown error here. So for I in range of R. So I is this number. Is it less than this number? Well, first thing first, I'm going to add a length of R for range of length for I in length. And then S, we're going to plus equal to an empty to a string to 1 here. just to get that one case out of the way. Length minus 1. So we're going to have to see the last one. Okay. I plus 1, which is 1. And we're going to take that number minus cur, which is 1. So 5 minus 1, and then add that to the rest. So the condition is if cur, if current num is equal to s at cur s at I hash map at s at I, and this is gonna be I plus 1 next num. If the current num, right, if the current num is more than, if current num is more than next num, then set cur, then cur num minus cur rest plus equal to cur minus cur equal to 0, cur equal to 0, and then go forward. Else, if it's not that, then we're going to do cur plus equal to cur num, and then in the end we're going to return rest. If my logic is correct, it should work. Right? Oh, Jesus. Output 0. So this is going to get me to I. But why is it output 0? It passes 0 test case. Okay, let's see what all the other one is. Okay, 55. Yeah, I. So plus equal to num. LV at I. It never added this last three number because it never got to the last one. Now we're gonna add so res plus equal to cur. Submit. Output at 2, it's better 3. Lengths. Submit again. Okay. Plus 1 minus 1. Let's add an extra case in here. Let's just add a 0, which represent a 0. That's the smallest number you can have. So we're going to add 1 to the string so that we don't get the out of range error. So we're going to have s plus equal to a 0. Because string concatenation, string is immutable, so it might have to create a new string for this. Oh wait, we have to do that afterward. We have to do that after finding the length. Otherwise, we're going to get the index out of range error. I'll put -1. How did we get -1? Oh, because Jesus, it's going to try to subtract that. Ah, man. But what about my normal case? Does it work? It's going to get an out of range error, isn't it? Okay, s plus equal to a 0. No, let's not do that. -1. Cur plus slash hash map at I -1, which is going to give me the last number. Yeah, we're close. Okay, so we test 2 to 3 case, but it's giving me 6 instead of 5, so which means we are omitting the last case. If the last number is bigger, So the reason why it's giving me 6 is because I take this number, right? Uh, what if I do from 1? What if we do 1 forward and backward? What if we do it like this? Why don't we look at this number? Is I minus 1 the number at I minus 1 more than the number at I? Yes, that's true. Go forward. So that way we don't get the out of bound error at the very end. Hmm. So either I have to do another conditional, which um, is hash map at I is more than cur, then do the other one. All right, let's try that. If hash map at s minus 1, s minus 1 more than cur, then take that number, take hash map at I minus 1 minus cur, else we're just going to add it res plus equal to hash map at uh, s minus 1 plus cur. And then we enter res. That should be it. Okay, I'm slowly giving up here. XX20. Is the current number or equal to? Yeah, it's kind of slow. Some of the kids be able to get this much faster. Yeah, it's consistently slow, and it uses a lot of memory. Let's see what the top solution is. Oh my god. Okay, so that's fine. NS. What does NS stand for? N is a length. IDX is the current index. Well, IDX is less than N. This is going to iterate through. IDX plus 1. If IDX plus 1 is less than N, and map at IDX plus 1, if the current number is less than the next number, then IDX plus 2. Else NS plus equal to the current index, and then increment the index. Yeah? That's basically what I did. Uh, Conversion. If the next number is more than this number, together is going to be minus equal to that. Yeah, minus equal to that. And then, oh yeah, that's genius. We can get subtracted from it. If it's less than, subtract it from it. If it's more than, add it to it. That's pretty genius. So if it's less than, we don't need this curve right here. We can just do minus equal to. We can just do that. We can just omit that actually. Rest is plus equal to curve. And if it's less than, then we can do minus equal to curve. Minus equal to curve. No. Res just minus equal to that. And we can omit all of this crap. So if it's more than, if the current num is more than the next num, then add it to it. Else, subtract it from it. Submit. I might get like an off by 1 bug here. 2, 3, 4. Let's see what we run it again. So in this logic, we don't even need this. So we got to the very last number, right? So what can we do to check the last number? Can we do range is gonna, if the next number is less than this number, which means we are omitting the last number. We got to the 5 here, but we're not doing anything about it. We're not adding to it. So if that number is more than the last number, well, it's always going to be less than this number for sure. What if we just do -1 here? What if we just start from 1 and we go from length to length? And that's going to check current num is equal to current range, previous num, right? If the current num is less than, if current num is less than, I mean this number is less than this number, nah, subtract from next from res. If cur no, don't do that, don't do that, don't do that. Or I can just do another condition down here. So if current num is equal to current num is equal to hash map at I, negative 1, 1, previous num is equal to hash map at -2. The current num is designated respectively to run, else to run. There we go. Indentation error. Shift tab. Else. Index out of range. D. Shoot. Mm. Mm-hmm. Let's go on the base case to see if it's passing. It should pass. So in this case, we only have one number. So let's go back to where we were and omit all of that. Omit okay. Anyways, that's the solution. I'm out of time. But the point is, we don't need cur to keep track of it. We can just add to res. Whenever we find a number that's less than this number, we subtract it from length. No. Whenever we find a number that is less than, whenever we find a number that is less than this number, subtract it from this number. So if we find a number that is less than this number, m is more than c, so we add that to the array. C is less than the next number. It's less than or equal to the next number. We subtract that from the array. So res minus equal to that. And we keep going until we find one big number that is bigger than the current number from before that. Then we're going to add that to the array again. So this part works. This part works. We just got to worry about this part right here. And that's checking the last number. And that is where the problem is. But yeah, that's the basic concept of it. Have a good day. Bye.